All right, let's jump right into this explainer. Today, we're tackling something that has literally kept every software engineer up at night at some point, choosing the right tech stack. I mean, when performance is on the line, how do you make a decision that isn't just based on a gut feeling? You know the feeling, right? We've all felt the pain of a totally messy software ecosystem. Applications just completely refuse to talk to each other, data gets trapped in silos, and your systems just bog down. But when it comes time to evaluate a new integration platform to actually fix this mess, the decision usually relies on whoever has the loudest opinion in the meeting room rather than hard, objective data. So the big question is, does it always have to be guesswork? Well, absolutely not. To solve this, we're building a data-backed playbook to rank your options objectively. We're going to start by looking at those messy software ecosystems, introduce the AHP methodology, define the three dimensions of performance, construct the actual platform ranking, and finally visualize that ultimate decision. Okay, part one, messy software ecosystems and the modern tech stack chaos. Let's be real for a second and think about your own company's ecosystem. Applications are almost always built in complete silos. They simply aren't designed to collaborate out of the box. Whether you're dealing with local clusters, sprawling cloud environments, or massive pipelines of big data, you absolutely need an enterprise application integration platform. Why? Because out-of-the-box software just flat out refuses to play nice together, and you need a robust tool to design, execute, and monitor all those moving parts seamlessly. Moving on to part two, the AHP methodology solution. This is where we go from guesswork to actual science. So here's where it gets really interesting. How do we bring rigorous science into what's normally a totally subjective choice? Enter the Analytic Hierarchy Process, or AHP. It sounds a bit academic, but it's basically a method that uses both math and psychology to organize incredibly complex decisions. Think of it as our secret weapon against software chaos. It takes those qualitative, gut-feeling developer opinions and translates them into strict, quantitative scores. It structures the whole problem so you aren't just blindly comparing apples to oranges. The way AHP does this is brilliant. It uses an inverted tree model. Picture your ultimate goal right at the top, which is achieving the absolute best performance. Then you break that down into specific performance dimensions in the middle layer. Finally, at the very bottom, you slot in your alternate platform choices. It creates this super logical flow that ensures every single platform choice maps directly back to that top goal with zero cognitive leaps. Which brings us to part three, the three dimensions of performance and measuring what actually matters. To actually get a ranking, every platform has to be scored on three core areas. First up, message processing. This evaluates how efficiently a platform handles messages and manages thread pools to boost your throughput. Second is hotspot detection. This is all about how well the system finds bottlenecks, those overloaded chunks of your integration solution that just drag everything down. And third, fairness execution. This measures how fairly the platform hands out computational resources, meaning threads, to different tasks, so everything processes in a balanced way without weird delays. Now here is the absolute game changer. How do we measure these? We directly compare subjective criteria against objective criteria. We take human expert judgments, which we score on a psychological scale from 1 through 9, and we smash them together with strict objective system properties that carry massive quantitative weights of 10 or even 100. By doing it this way, we guarantee that hard data prevails over human bias, while still actually caring about the nuanced, real-world experience of your engineers. To give you a concrete example, let's look at that message processing dimension. A platform is going to score way higher, objectively, we're talking earning a 10 instead of a 1, if it features local thread pools rather than just a generic global one, or if it uses dynamic thread pool configuration instead of a static one. Also, hybrid message stores mathematically crush simple in-memory storage because they can actually handle massive big data demands by falling back to disk storage when they need to. And then you have hotspot detection, basically catching bottlenecks before they completely tank your system. Think about it. A platform that automatically detects hotspots at runtime using pattern identification, that's mathematically going to dominate a platform that relies on manual design time guessing by your team. It's the difference between a system having the brains to monitor itself versus just crossing your fingers and hoping your team perfectly predicted every single traffic spike during the design phase. All right, part 4, constructing the platform ranking. Let's look at the actual playbook steps. The workflow here is a 4-step process. First, dimension relevance. That's where you assign weight to what matters most to you. Step 2 is platform competence, which combines those objective and subjective scores we just covered. Then comes step 3, score computation, where you mathematically merge all that data. And finally, step 4, pairwise comparison. To get your absolute winner, you calculate the final score by multiplying the platform competence scores by the relevance weight of each dimension, and then validate it all through psychological pairwise comparisons. So when you're assigning those relevance weights, you've got a scale. 3 is essential, 2 is important, and 1 is just desirable. This is crucial because it lets you mathematically prioritize what actually matters to your specific company. For instance, if your current architecture is plagued by terrible resource bottlenecking, well, fairness execution is critical, so you'd weigh it as an essential 3. This ensures the final score reflects your unique business needs, not just some generic industry benchmark. Next up is pairwise comparison. This is all about evaluating 2 platforms head-to-head to remove cognitive overload. The psychology behind AHP is fascinating here. It proves it's so much easier and way more accurate for an IT team to compare just 2 platforms directly rather than trying to juggle 5 in their heads at the same time. You literally just ask, is platform A better than platform B at message processing, and assign a value. The math then checks the consistency of your answers so you don't accidentally contradict yourself later. Finally, part 5, visualizing the final decision, the big reveal. Once you've crunched all those numbers, you need a bulletproof way to show this to the business leaders who are actually signing the checks. A stacked bar chart is the ultimate payoff here. It visually proves which platform wins overall based on the total width of the bar, but it also shows exactly which dimensions gave it the winning edge. The dark gray is the partial score for message processing, the light gray is hotspot detection, and the white is fairness execution. You instantly see not just who won, but why they won, making your recommendation pretty much undeniable. Now, when researchers actually tested this playbook on 5 massive open-source platforms, heavy hitters like Spring Integration, Camel, and Guarna, the differences in those objective properties became wildly apparent. Take a look. Notice how Camel uniquely features runtime hotspot detection, whereas Spring Integration and Guarna rely on design time detection. Or how Guarna uses a task-based execution model compared to the process-based model of the others. The hard data really separates the tools from one another. Distilling those results down, we see some genuinely fascinating stuff. Only Camel detects hotspots during runtime. Only Guarna adopts a task-based execution model, which, by the way, handles steady streams of data beautifully. But actually, the most surprising takeaway? Even among these industry-leading platforms, absolutely none of them offer dynamic thread pool configuration. They all use static pools. It just goes to show no single tool is absolutely perfect out of the box. You really have to find the one that best fits your heaviest needs. So I'll leave you with this question to chew on. Is your current integration platform truly the best for your needs, or was it just the loudest in the room when the decision was made? Next time you're tasked with upgrading your tech stack, I challenge you to ditch the guesswork. Apply the step-by-step AHP methodology, weight your dimensions, run the pairwise comparisons, and let the data actually make the decision for you. Thanks for joining me on this explainer, and happy integrating.